We're going to go ahead and take a look at a confidence interval for a single proportion. So just as a reminder, our standard error for our samples proportion is the square root of our p times 1 minus p over n. Now, what do we do to make our inferential statistics, in this case a confidence interval, when we don't know what p is? Well, we estimate it with p hat, because that's our best guess for what p is. So, to do our confidence interval, in general, you know, it's your statistic plus or minus z star times your standard error. Now, remember, being a proportion, we can get our standard error from that square root of p hat times 1 minus p hat over n. Now, we had said this was p before, but we're estimating what p is with our p hat, our sample statistic. And our sample statistic is what goes in front here. So in general, this is how you do your confidence interval. For proportions, this is what we're going to use. However, remember n times p has to be greater than or equal to 10, and 1 minus p times n has to be greater than or equal to 10. For it to be normal, that comes from the central limit theorem. So let's go ahead and try this one. See if you can construct a 95% confidence interval. If you want, you can go ahead and pause the video, try to do it on your own, and then play the video again. So, the first thing we have to do is see if we're greater than 10. So, we take n, our sample size, which was 1,000, times p, our probability, and that is 320 divided by 1,000. So that's how we get this, 0.320, and multiply them together, we get 320, which is greater than 10. Or, when we do the 1,000 times 1 minus p, we get 680, which is also greater than 10. So, that's good. So we have greater than 10 in each category, so we know it's going to be approximately normal, so we should be able to approximate our confidence interval going ahead and using the normal distribution. Now, in the past, we had said our z for our confidence interval was going to be 2. But we're going to try to be a little bit more precise, and we're going to use the actual value of z star being 1.96. So we're going to have to take our proportion plus 1.96 times the standard error right here. So here's our proportion. Here's our z star. Here was our estimate of our p, which is 0.32, times 1 minus 0.32 over our sample size of 1,000. So we get our statistic plus or minus 1.96 times 0.015. So when we add these together, we get 0.349. When we subtract these, we get to 0.294. And I'm assuming you can do that on your calculator. So we're going to say we're 95% confident that between 29.1% and 34.9% of the U.S. adults favor sin taxes on soda and junk food. Now, if you were to go ahead and do this on StatKey, and that's what we had done before. If you were going to do this on StatKey, you'd want to pull up StatKey, go in the center column because we're dealing with confidence intervals. We were dealing with one proportion, so you go down to a confidence interval for a single proportion. Then at the top, you go ahead and edit your data, put in your count of 320, put in your sample size of 1,000. Then you'd want to generate about 5,000 samples. Then you'd want to hit two-tail. It's going to pull up 0.95 here in the middle, which is what we're looking for. And you notice the confidence interval that we would get from StatKey matched what we had on the last screen. So our margin of error is what we add or subtract to our statistic for our confidence interval. That's what's to the right of the plus and minus. So that was our z star times the square root of all this, which is our standard error. Now, we could work this backwards and help our standard error determine our sample size, because sometimes you want a certain amount of standard error and you want to know how big of a sample do I have to get so I will get that standard or margin of error. So basically, if you would use some algebra up here, solve it for n, you would get this formula. I am not going to expect you to have to go ahead and solve this for n to be able to get this formula down here. We'll just go ahead and take this formula. Now, let's go ahead and take a look at what we would get if we were dealing with 95% confidence interval. Now, we're going to estimate our p hat with 0.5 for our p. That makes a very conservative amount. Now, if we had something like 0.4 or a 0.3 or a 0.1 here, it's going to make this smaller. So the biggest this will ever be for our sample size to be on the conservative side, we're going to use 0.5. For our 95%, we're going to approximate z star as 2 because it'll work out quite nicely. So we'll go ahead and put 2 in for our z star. We'll put in 0.5 for our p hat and our p hat. Now this is 1/2, and then in parentheses is 1/2. 1/2 times 1/2 is this 1/4. All of a sudden there's a 4 that shows up, but over here I had a 2 and I had to square it. So 2 times 2 is that 4. Also take my exponent and apply it to the standard error. Notice I'm multiplying fractions. I have a 4 on the top, a 4 on the bottom. They're going to drop out. And so I end up getting this. So my sample size for a 95% confidence interval can be approximated as just 1 over your standard error squared. So let's go ahead and estimate our sample size that we would need if we wanted a standard error being 0.03. So this is our formula for a 95% confidence interval. If it was not 95% confidence interval, we'd have to go back and use that whole original ugly looking formula. So we're going to go 1 over 0.03 and then square that. Typing that into our calculator gives us about this. So we're going to say our sample size has to be 1,111. Our sample size of that, or even slightly larger, will give us a standard error of 0.03 that we were looking for. So, what proportion of people can curl their tongue? It's either a yes or a no, so we're going to be dealing with a proportion. We want to visualize and summarize our data. We want to give our point estimate. We want to give and interpret our confidence interval. So, theoretically, 75% of the people should be able to roll their tongues. But let's see what happens with the data that we collect. So we ask people yes or no if they can roll their tongue. 73% said yes. So 73 out of 100 said yes. So we could go ahead and visualize this with StatKey using our confidence interval of a single proportion. You would want to go ahead and edit your data, putting in 73, your sample size of 100. Go ahead and generate 5,000 samples, hit two-tail to get your confidence interval, and we get this to show up here. It also gives us our standard error. So what is our point estimate? It was at 0.73 because that was our percentage. You'll notice down here it ends up being pretty close to that. It's 0.731. Now, we want to give and interpret our confidence interval. We had this right here from the last slide. Our confidence interval is 0.640 to 0.823, or 0.820. So we would say we're 95% confident that the true proportion of people that can curl their tongues is between 0.64 and 0.82. Now, we could also have done it with that formula. So we could have also came up with our confidence interval with this, and it would have given us pretty much the exact same thing. So there'd be two ways to be able to come up with our confidence interval.